With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, consider a head-on collision between two particles of masses m1 and m2. The initial speed of the particles are u1 and u2 in the same direction. The collision starts at t equals 0. Particles interact for a time interval delta t. During the collision, the speed of the first particles varies as vt equals u1 plus t upon delta t v1 minus u1. Find the speed of the second particle as a function of time during the collision. So we need to find the speed as a function of time during the collision. So we know in this question we will apply conservation of linear momentum. Okay, suppose these are the two masses of mass m1 moving in this direction with velocity u1 and m2 moving in this direction with velocity u2. It is given that its velocity during the time of collision can be written as vt equals u1 plus t upon delta t v1 minus u1. Okay, so this is given. So for conservation of linear momentum, we know initial momentum equals final momentum. Initial is m1 u1 plus m2 u2, as both are traveling in the same direction, so there will be a positive sign between them, and m1 into u1 plus t upon delta t v1 minus u1 plus m2 and v2. This is the v2 we need to find out. So from here we can easily see that this expression gets cancelled out with this expression, and this comes out to be m2 u2 minus m1 t upon delta t v1 minus u1 equals m2 v2. So now, because we need to find only v2, that is the velocity at the time of collision, we need to find v2 at the velocity during the collision. v2 comes out to be u2 minus m1 t upon m2 delta t v1 minus u1. So this is our final expression. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.